Okay, so today I want to start looking at variables in Java. And again, what you're going to see is a lot of this is very similar to what you learned last year in C#. So what I'm going to present to you will be partially just theory, but mostly we'll do this through example like we did yesterday. So we'll do some programming in NetBeans. So if you haven't, as you're listening to me, start up NetBeans and just load up the example that we did yesterday. We'll just continue from there in that same example. Okay, so remember what a variable is it's a piece of memory that you have taken from the computer that holds a value and is named, like you give it a name, okay? But in order to do this, you also need to give it what's called a type. And a data type will define what goes into that variable. And the type of variable defines what it will store. In Java, these data types are built into the language, and later in the course you'll find that data types can get more advanced, and you, the programmer, can start defining the data types. It's a little more advanced, and that's where classes comes into play, okay? So the name of the variable or the identifier is how it will be referred to in your program, and it stores objects as a reference, and it can store values. Now that's kind of a bit more of an advanced statement that will again be something we'll lead into later in the course. And the reason it's called a variable is because what's inside of it can vary. It can change, okay? To create a variable, you need to declare it. You need to write a line of code that will create the variable so that you can use it, okay? So there are a number of basic data types within Java. And in reality, they're almost identical to the same data types that were in C#. These are also known as primitive data types or atomic data types or built-in data types that generally are called primitives that are part of the Java language. And Java has 8 of them. The byte, the short, the int, the long, the float, the double, the char, and the boolean. The good news is you will not need to use all of these in this course. In reality, you'll only need to use a much shorter version of this list. Probably 4 out of these 8 and not all 8, okay? But I will explain them to you. They are available to you, but chances are you won't need all of them, okay? So to create a variable in Java, it basically, again, just like in C#, is where you create the line of code that gives the data type, and then its name, and then a value. Now, the slide I have up here is actually from when I used to teach Visual Basic in the grade 10 introduction course, but we don't do that anymore. I do it in C#. So the good news is you don't need to worry about that slide. That is old news now. So here's how it's done. And hopefully that looks familiar to you. That's very similar to the way, well, it is exactly the same way we did it in C#. That's the data type, that's its name, and here's its starting value, and it ends in a semicolon. Okay? Okay, so here are the basic data types in Java. And again, I'm going quickly through this. This is basically a review, okay? So the data type called byte is very small. It ranges from -128 to +127 and includes 0. So those are the numbers that it can store. Any number in that range. No decimal places, okay? No decimal places whatsoever. And it uses 8 bits of data to store each of the variables. Now, I asked this question to you guys last year, and remember if you can sort of recall why. Why is there one more on this side, -128, as opposed to this side, which has +127? Why does the negative side get one more? Why? That's right. It counts 0 as a positive number. Hello? Okay. So you're right. So because 0 is considered by the computer to be a positive number, it allows for one more on the negative side. Like if you just took all the numbers and divided them in half, because now 0 is counting on the positive side, there's room for one more on the negative side. Now again, this is stranger than math, because in math class, 0 is considered signless. It's supposed to be a value that has no sign to it. But the computer can't work that way. The computer doesn't work on theory. It needs to be defined. So in computer science, 0 is defined as a positive number, okay? The data type called short is a little bit bigger than that. So now we're moving up into the thousands. So now you can store numbers up to 32,000 or up to negative 32,000. Now, why is it not a round number? Any idea why it's 32,767 and it's not just like 3,200? Why do you think it's not a round number? Well, the reason is round numbers like 3,200 are numbers that make sense to us using the math that we're familiar with, which is numbers that go up to 10 and then go up to 20, etc. We use what's called a base 10 math system. We use digits 0 through 9, which are 10 digits, to define our math. But the computer doesn't do that. On its end, it uses a base of 2 numbers, 1 and 0. And when you convert that into the type of math that we use, it comes up with these numbers that look weird to us, but in reality, they're actually very whole numbers to the computer, just in the fact that it uses binary numbers, okay? Again, no decimal places, and it stores numbers a little bit higher. Then there's the integer, okay, or int. This is the one you used last year, and this is the one you're going to use this year as well, okay? As you can see, it can hold numbers into the billions in size. So it can hold 1 billion up to 2 billion in size. And that's the data type I want you to use this year if you're storing a number that doesn't need decimal places. That's the one you use, okay? That's the good news. That's exactly basically the same as it was in C#. There is one even bigger than that. And there might be a time this year that you may want to experiment with this one called the long. But the long, as you can see, has a huge range in numbers. It goes into the millions, then the billions, then the trillions. Anyone know what comes after that? What comes after trillion? Because then after that we go, well, even one more. This is the point where you say something like gazillion and pretend like it's a real number. But I don't know what it's called, but it's quintillion. And then what's after that? So that's what we're looking at here. That is the largest possible number that Java could store in a primitive data type, which is big. Now, I doubt you're going to write software that's going to need a number that big, unless you think of some crazy piece of code that would like to use such large numbers, which is why I think integer will always be good enough for you to use. Okay, now, there are times you're going to need decimal points. And there are 2 data types that can use to do this. One is the float, okay? The float does work, but it's a little bit smaller than the data type that I am going to suggest you use, and you may recall it's the same one from last year, the double, okay? The double holds large decimal numbers, okay? So it has the ability to store numbers as a decimal. So it theoretically can store things like fractions and stuff like that. Whereas integer can't. Integer is always just going to be a whole number. So just like last year, the only 2 data types you need to worry about when dealing with numbers is integer and double. And you only need to use double if you need decimals. If you don't need decimals, you use integer. That's the simple way I would break down the way you're going to use variables this year. Now, this one is one I introduced last year in grade 10, but you probably didn't use it much or at all in grade 10, but you will be using it probably this year, and that's the type char or character, okay? Character holds one single character, just one, okay? It's not a string. It's not a collection of characters. And what it is it is one character, and when you define it, when you create a variable of its data type, you use single quote marks or like apostrophe characters to define what's being stored in there. And that doesn't have to be a letter. It can be any character. So it can be exclamation point. It could be a space. It could be a number, right? It's holding it as a character. Okay, so it's like a string that only holds one. And it's not a string, so it uses less memory than strings do. Okay, and then there's one that I also introduced to you last year, the Boolean. It's the simplest data type. It only holds 2 values, true or false. Java, strangely, which is different than C#, uses the entire word Boolean when you define a Boolean variable. You may recall in C# and in the C++ language, it just uses the word bool, a shorter version of it, like int as to represent integer. But for some reason in Java, they decided to lengthen it out and make it the whole word Boolean. Whoops, so there's an example of a Boolean. Right, so it's just either going to be true or false. And notice the words true and false appear as blue keywords or reserved words. Okay, rules. There's some rules when you name variables. Okay? Java has the same basic rules that you learned in C#. They are the same. So here is where a possible error could occur. If you start using uppercase letters when you shouldn't, you're going to get errors. And actually, if you remember something I said yesterday, if you see an uppercase letter at the start of a word, it's a clue to you that something's going on. What is that clue? That it's a class, right. So when I see this, if I said char, that should be that means that this is a class, which it's not. It's just a basic primitive data type, so it would be wrong, okay? So that little clue will help you to say, whoa, don't use a capital letter there. Okay? So the fact that this language is so picky about upper and lowercase letters will actually will frustrate you at first, but it makes you a better programmer. You have less bugs because you're thinking about your code a little bit more. And it actually makes for much faster code. Programming languages that have kind of allow you to be sloppy in the way you code actually run a lot slower, okay, in general. Okay. So now, you can use letters in the name of your variable. You can use numbers in the name of your variable. And then there's two other characters that you can use that I don't recommend, but you can actually use $ and underscore characters. The underscore occasionally is useful, and I'll go over that in a minute. The $ I would never recommend you use. Okay? It's got sort of special meaning that is beyond this course. Okay. You cannot, however, begin the name of a variable with a number. Although you can allow numbers in the name, you can't use them at the start. Okay? Case matters, upper and lowercase matters. I just went over that. Again, I don't recommend $ and underscores. And the style that I would recommend is to use that camel casing style again, where you upper case new words. Okay, so here's an example of 4 legal variable names. First letter X, X232Y, and this is a very long name. Notice in this is a very long name, I'm using the camel casing to put an uppercase letter at the start of each word to create that visual cue to help you better understand what I'm saying in that name. These are illegal variable names. Can you tell me why? What's wrong with the first one? Starts with a number, right. That's not going to work. What's wrong with the second one? Right, the dash, illegal character. Third one? Exclamation point, illegal character. And the fourth one? Right. The space isn't an illegal character, but what it thinks is that this is the name of the variable, and then it has no idea why you're writing another variable here. It's like, wait a minute, what's going on here? I don't understand. So it's not that the space is an illegal character. It just thinks that you've started a different piece of code at that point. So yeah, and those are simple mistakes that Java should catch for you. And again, as it says right there at the bottom, you can't also use keywords. So for example, you couldn't make a variable called false because that's a reserved word. You couldn't make an integer called int because it's a reserved word. And you know it's a reserved word because it'll appear in blue. Okay, so now we got them. What are we going to do with them? Well, you can do math with them, obviously. And the basic 4 math operators in Java, addition, subtraction, multiplication, and division, are the same. But you may recall again from your math class and from last year's computer science class that there's a precedence order to this, which means there's an order to the way it does the math. Okay? So I'm just going to put up these to explain that. You can in Java just negate variables just like you can in regular math by putting a minus sign on it. That just makes it negative. You can add them, subtract them, multiply, divide them. And then for some of you, you may recall the percentage sign is a special type of division called modulus division. Does anyone remember what that is? Probably didn't use it last year, but I did talk about it. What does modulus division do? Okay, we'll get back to that. That's okay. You don't have to know. I'll remember in a second. I'll show you what it means. Okay, modulus means that when it does the division, it does not give you the answer of the division. It gives you the remainder, which you may remember back in the days when you first learned about division. is something that you get when you do a division. So, for example, 29 divided by 3 is what? What's 29 divided by 3? Well, it doesn't matter when you use modulus. What matters is what's the remainder. And the remainder of the division is 2. Right? It's 2. Because 29 divided by 3 is 9, remainder 2. And that's what modulus gives you. There are times when that is actually useful to you in your programming. Okay, constants. Who remembers what a constant is? A constant is a variable that, oh, sorry, you were going to say? That's right, it can't change. It's a variable that never changes. We have these in math, too. Things like pi and delta and stuff like that. They're variables that, well, not delta, but pi, for example, is a variable that never, ever changes. Okay? And you should use these in Java as well. And you may recall the way you do them in Java is exactly the same way you do them in C#, which is to create them and give them a value. But in Java, it uses the keyword final. Here's one of those weird little quirks about Java. In C++, just like in C#, they use the keyword const to represent a constant, which I thought was a really good word. But for some strange reason in Java, they switched it to the word final. I don't know why they did that, but it is a bit of a change. So here, for example, is how you'd create a variable pi that's a float, but by adding the keyword final at the front of the variable declaration, now this variable can never be changed. It's locked in. The other thing that I taught you guys last year about constants is the style changes. The way you write constants is to write them in all capital letters so that they stand out on you. Okay, you may recall this from last year. This is shorthand. But if you want, you can easily add 1 to a variable by just using the plus plus symbol or the minus minus symbol to subtract 1 from a variable. So again, for example, you could do stuff like this. More count plus plus means more count equals more count plus 1. It's just shorthand. You don't have to write code that way. If you're fine writing more count equals more count plus 1, write it. Same with this. Less count minus minus means less count equals less count minus 1. That's all it is. Okay, now if you want to get even more shorthandy, this is an example of some other stuff you can do, and this was, again, available in C# as well, is you can put plus equals, minus equals, even multiplies equals, divide equals, and even mod equals to mean the same as x equals x plus y or x equals x minus y. Now these I don't necessarily recommend unless you really grasp what's going on here, because if when you look at code like this in the future, it might be really confusing as to what's going on. But that being said, I won't deduct marks if you do this. If you want to be an incredibly lazy coder and type less code, that's great. This will work for you. It's more efficient in the sense that you have less typing to do. I just think it's a little bit harder to read, especially as you're getting started programming. But absolutely, you can use that if you want. Okay, so let's see if you can grasp this. What would this spit out? What would this piece of code spit out? I'm going to tell you right now there's no errors in this code. The code has no syntax errors. The question is, what would the output be? So you look over those variables and the code that I've written, what would the output be? Anyone want to take a guess? Okay, so let me try and assist you a little bit. So what I'm outputting is a character plus a character plus a character. Now, the characters, for example, are up here. They're defined as letters. Now, am I actually adding them? Can you add L plus A? Can you do that math? No. You can't actually add them together. But what would happen if you were to attach two characters together? They would join together. So L and A would join together to become LA. Does anyone remember the fancy word for that when you were connecting characters or strings of characters together? There's a fancy C word that describes that. It's a long word. No? It's called concatenation, when you concatenate things together. So anyways, can you see what the first part would be? It'd be L plus A plus R plus R plus Y. And then it would concatenate on these characters, is a. So it's Larry is a. And then it would give the value Z. So what's Z going to be? That's right, Z is 0. Okay? Because it takes X minus Y, which is 6 minus 15, but it's also timesing it by 5. And remember, multiplication is done first. So it would really be 5 times 6, which is 30, minus Y, which is 15, and that's 15. So you might think it's 15, but no, because it says Z equals Z times itself. And Z is 0, and anything times 0 is 0. Okay? So that's what the output would be. Okay. Now, just like in C#, you can turn one data type into another. And it's going to become a necessary evil in Java as well, is Java likes to always work with the same data types. So if you have an integer and a float, it doesn't like it when you try and do math with the two. It wants you to make everything an integer or make everything a float. So in order to do that, to convert one type to another, okay, there are a couple different ways to do it. And the most simple way at this point is called casting, where you are casting one data type into another. So here, for example, is a potential problem. I have an integer called count, and I have a double called score, which has a decimal value. And I'm going to try and divide them. Should the answer have a decimal or not? Should 10 divided by 6.5 have a decimal at the end? Well, according to what I've defined here, it shouldn't have a decimal because it's an integer. But the math might think, well, wait a minute, 10 divided by 6.5, the answer will have a decimal. So Java gets confused by this, and it doesn't like that. It doesn't say, whoa, 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 I don't like that you're doing this. You can't do this because my answer would be a double. So instead, what Java would like you to do is convert them to one data type or the other. Okay? And this is, again, the simple way to do this is called casting. And here it is. Again, so I have x is 0. It's an integer. I have y, which is a double, and it holds a decimal. So they're two different data types. What I can do to turn to turn y into an integer, so instead of being 7.8, I want it to be an integer, is I just put the word int, what I'm turning it into, in brackets right beside it. It's almost like I'm multiplying it by an integer. It's not, but that's what I'm doing here. This is called casting. So what do you think 7.8 would be as an integer? What's your guess as to what it would be? That's right, it's 7. If you thought it would be 8, because it would round it off, you'd be wrong. The computer doesn't do that kind of complicated math. Rounding off would require the computer to look at this and go, well, is this thing higher than 5? That's more than the computer wanted to do. All it does is it takes the 0.8 and throws it away. That's called truncating. It just tosses that part of the decimal part away. It just throws it out. So even if it was 7.9999999999999, it would just be 7 because it throws the decimal part away. It never rounds it off. Okay? And I can go the other way as well. I could turn x into a double, and 0 as a double would be just 0.0. But that's how it does it. So this slide here is an example of all different types of conversions. You won't need to do this, but you can turn B, for example, which is a short, into a byte. You can turn bytes into doubles. You can convert all these number types into other number types. And that's what we're talking about here. We're talking about turning one data number type into another. Because in reality, all you got to worry about is integer and double. You don't need to worry about these other data types. You can experiment with them if you'd like. But as long as you just focus on integer and double, then you don't got to worry. Okay, that's enough. We're going to stop there for a second and try some coding now. We'll leave string for a second. Okay, So everybody load up yesterday's example. Hello world, goodbye world, and exit. And leave some space between the exit and where we are now. Okay. So at this point, let's create our first variable. We'll make an integer. We'll call it A, oops, because we're not creative in our names. And let's give it the value 10. Okay? So that's it. That's how you make an integer. Very simple. Let's make a double. We'll call it B. And let's make it 10.5. So now we have the ability to use decimals when we make a double. So those are the two number types that you have to worry about. What's another data type I just presented to you that we could possibly use? No, I didn't present string to you yet. But you're on the right track. Char or character. This holds one character. So let's just call it C equals. Now we have to give it a value as well. So when you give a character a value, you use single quotes or apostrophe characters, and you can put whatever you want inside of there, any character you want, but it has to be just one character. Okay, that's 3 data types. There's at least one more that I presented. Yep, but let's not use that one. Not a number. It's not a number. It's the simplest data type you could possibly think. Boolean, right. And here's where it's weird. It's B-O-O-L, but you have to keep going in Java. E-A-N, Boolean. In C# and in other programming languages, by the way, most programming languages, it's just bool, but Java likes it to be Boolean. It likes to really flesh it out. D equals true. So remember, Booleans are just true or false. So in reality, that's it. That's the 4 basic data types that'll get you through this course. With the one big exception, the one thing that's missing is something you already mentioned that you knew last year, the string. Okay? The string is still missing from this, but strings in Java are a little more complex. So I'm going to introduce them either later today or on Monday to you guys. But there's 4 data types. Okay. So let's do a little bit of math with them. Let's take A and add 1 to it. Let's shorthand that. A++. So that means A equals A plus 1. Let's take B and subtract 1 from it. So let's go B minus minus. So those are 2 shorthand methods of taking A and adding 1 to it and taking B and subtracting 1 from it. Okay, let's see if this is actually working. Let's output our variable. So last class, I told you guys that there are ways you can automate your code, especially if you're lazy and you don't like typing. Because remember, yesterday I taught you guys that this line, system.out.print bracket, hello world, will produce output. Now you could do that again. You could go system dot, and at this point you will take advantage, hopefully, of the autocomplete feature. But I'm going to jack it up one more level for you guys. Okay? I want to go back to here, and I did mention this yesterday, and who sees if they can remember? What if I don't know how to spell system? All I can remember is S. Can I get Java to help me? Right. If you hold down Control and press space, it'll bring up all words that start with capital S. And as you start typing system, it'll finish it. But wait, I got another shorthand thing for you. This one is even a more powerful tip. Java has a few built-in automatic keyboard shortcuts for very common phrases like system.out.println. I do not need you to know how to do this. You will not be tested on this, and I don't care if you ever use it or not. Because if you like typing, then don't bother. But if you're like me and are super, super lazy, please watch as I do this. If you just type S out, all in lowercase, sout, and press tab, it will automate that line of code for you. Allow me to demonstrate that again. I just go S out and press tab. How sweet is that? Okay, so all I'm going to do is I'm going to say A equals plus A. Now remember, what's going on here is it's taking this thing here, which is stuff inside of quotation marks, and then it's taking this thing, which is a variable I declared up there, and I did a little bit of math with right there. And is it going to try and add those two things together? Is it, because right here it's saying use that symbol, which usually means add. But is it actually going to add them? Is it going to add some quotation mark stuff with a variable? It's going to not add them, it's going to join them. And what is that word? To join things together? It starts with a C? Come on, you can do this. It's like scramble. Concatenate. Concatenate, fancy term, means to join together. Okay, so let's see if this works. Let's run our code and let's see if A gets outputted. So run your code. And Java's a little bit sluggish always the very first time it runs code. And come on Java. There we go. Now we didn't put line breaks in there, but here you can see that it's outputting A equals 11, which is very much the right answer. Now, why is it 11? Well, it's 11 because it was 10 when we first started, but then we added 1 to it. So now it's 11. Now, I'm kind of annoyed by the way that output went, so I'm going to take a minute to delete the first 3 lines. And actually, I'm not going to delete them. I'm going to teach you guys a neat little NetBeans trick now. There are times when you have 3 lines of code or, say, multiple lines of code, and it might be causing a problem, like this is. It's not causing a logic problem, but it's screwing up my output. And you might want to be tempted to actually just delete it, like just hit delete and get rid of it. But let's say this was an actual programming problem, and you realize later, oh, shoot, I need that code back. And you got to go then spend the time to actually type it all back in. Well, you don't have to do that. You can take this code and turn it into a comment. And as you recall, when it turns it into a comment, the Java will ignore it. But you can do that using a little keyboard trick, which well, not a keyboard trick, but a little toolbar button. And the toolbar buttons are right here. Okay? Sorry, the computer's a little bit sluggish, but there we go. These 2 buttons right here will turn your code that you've highlighted into a comment or not turn it into a comment. And I'm going to show you right now. I'll click that one. Now it's a comment. And I click the one beside it, and it uncomments it. So that's a quick way that you can just sort of get rid of your code without really getting rid of your code. Again, just trying to show you a couple quick tips to make your coding life go more fluidly this year because you're not beginners anymore. So it's easier to sort of master these programs now. Okay, so now I'll run it. It will now have ignored those lines, and now you can see it just says A is 11. Perfect. Now I'm going to try the next one. I'm going to output B. B equals plus B. And while I'm at it, let's output the other ones. Let's output C. C equals, oops. And lastly, D. Okay, so I'm outputting my 4 variables. A, B, C, and D are being spit out onto the screen. And before I run my code, let's see what it should say, if I just sort of logically think through it. If I think through it, it should be the case that A, which is 10, should be outputted, but wait a minute, I added 1 to it. B, which is 10.5, should be outputted, but wait a minute, I subtracted 1, so it should be 9.5. It's going to output C, and all C is the capital letter A, so I should see that appear on my screen. And D, which is true, so it should appear, that should appear on my screen. So I run my code, and that's exactly what pops up there. 11, 9.5, A, and true. Okay? So variables are just places you can store data. You can do math on them, and you can do all kinds of crazy stuff with them. And you can spit them out if you need to. Okay. Anyone not caught up to where I am in this example? Okay, so now let's get a little fancier. Let's make an integer called e. I'm just going alphabetically at this point. Integer e equals, and I'm going to just do this, b. Now that will instantly register an error. Now let's see if we can figure out why. It says b and e should be equal. Well, b is a double, right? It's a decimal value. And e, I just said, should be an integer. So it's like, whoa, whoa, whoa. Those are two different data types. And actually, if you put your mouse around the error here and you start looking at it, you'll notice sometimes either an exclamation point comes up here or a light bulb will come up there. Now, what does a light bulb usually mean? If you were going to design an icon that's a light bulb, what would that be for? When have you seen light bulbs in the, other than, you know, in lights? Like, what is a light bulb? If you saw a light bulb on a book, in a book, someone drew a little light bulb icon, what would you think that would mean? An idea, that's right. The Java has an idea for you that it can try and fix this. And when you see that light bulb, if you ever see it, you can put your mouse over it and it'll tell you what it thinks. It says, you know what? There's a possible loss of precision, which means accuracy. It says required integer found a double. It says, I got an idea here. So in reality, if you click on the light bulb, it'll actually give you a suggestion. And what it says is cast B to integer or change type of E to double. And both of those are good suggestions. Watch as I click on the bottom one. It turned E into a double, and that fixed the mistake. But then the other way I could have fixed this is the top one, which says cast B into an integer. And that's what I showed you in the presentation. That's a way you can turn one data type into another. But at the same time, you can use NetBeans to help you through your problem sometimes. If you see that light bulb pop up, it might give you a good idea. It might not. The idea it presents might be absolute garbage. But it's a way, again, the whole idea with computer science is to solve the problem, right? To get through the problem. So there, that fixed that. Okay, so now let's try this. Double F equals A. Now you'd think this one would also be a problem. Because A, if you recall, was an integer. And it's saying F, which is a double. But it's not giving you a problem this time. Because in reality, it can do that one a lot easier for you. What's 10 as a decimal? Right. So it can do that one so simply. But to be a good programmer, we should probably do the conversion anyways. Let's go and put double here and let it convert it anyways. That's more accurate, although it's kind of unnecessary to do that. But it does actually work there. Okay. One more thing, then we're going to wrap today. Yeah. The last thing I wanted to show you guys today again is the idea how to make constants. So let's make a constant right now. Let's make it a double. We'll make the classic example, pi, the value pi, pi. And we'll give it the value of 3.14. What's the next decimal? Anyone know? After what? 1.5. Does anyone know anything after that? 9.2. Is it 6? Is there a 6 in there? You guys are just guessing now, aren't you? You're trying to fake me. You guys are like the worst poker players ever. And I believe you right now. I don't believe you. But let's go with that. Okay, 3.141592. Okay, I have to actually look this up. You guys are, whoops.
I just did.
And what is it?
3.141592653559.
Okay, give me the next 5 after 1.4. 3.14, 1.5, 9.2, 6.5, 3.5. Good enough. We'll stop there. I just wanted to show you. Like, let's say you wanted to make that. And remember, one of the reasons you make constants is that you don't have to keep writing that every single time you're going to do some big program. You don't want to keep writing that number over and over again. You can just use that, which is much easier. Same reason we do it in math. We don't keep writing it over and over again. We just put that symbol there. Well, we can't use the symbol because it's hard to type on a typewriter. But this is still not a constant yet. In theory, on the very next line of code, I could make pi into 0. I could change its value. To lock this in so that it cannot be changed, at the very front of this line of code, you put the keyword final. At that point, pi is locked in. You can't change it. And I'll demonstrate that right now. I'll go pi equals 0 on the next line of code. And look at that. I'm going to get an error. And the error says, cannot assign a value to a final variable. And final means constant. So it's locked in. Okay, let's make sure this all worked. Let's output E, F, and pi. E equals F equals and pi equals. Okay. One quick thing right here. You remember I showed you the control spacebar. Once you've made a variable, like I've made pi, if I put capital P and then control spacebar, the variable I made will show up in the control spacebar now. So once you've made a variable, then you can use control spacebar to find it in your list there. So again, these are little tips that NetBeans can do that will make your coding life a lot easier once you get rolling on this stuff. Okay? So I'm going to hit play, and the last thing there is I'm going to make sure my output is exactly the way I defined it, and yes, it is. It looks great. Okay? That's it for part 1.